All right, good morning everyone, and thank you for sharing your morning with us. Welcome to our second webinar on BIM for building product manufacturers. My name is Phil Marshall, and the webinar is one of a series offered by MicroCAD on the use of Autodesk tools and data platform to enable manufacturers to collaborate with architects, builders, and other partners on the building project. The first webinar last week focused on the business needs and workflows associated with sharing data. In our webinar today, we'll look a little deeper into the technical details of how data is actually shared. As a company, MicroCAD empowers design professionals in construction manufacturing industries to increase productivity and meet project goals. With 30 years of experience as a minority-owned business, we pride ourselves on working with clients through every stage of the design process to assess needs and provide tailored and effective solutions. Today, we are focusing on the detailed functionality to enable design collaboration. Design collaboration is where multiple people can participate in the design process and share information synchronously. This is clearly where the biggest benefits of BIM are. Autodesk has taken this concept and put it on the cloud. This webinar is intended to show you how building product manufacturers can share data with architects. We will demonstrate the software's functionality using simplified models so you can focus on the process. The Autodesk product highlighted here is Inventor, a full-function CAD/CAM system for product design and manufacturing. We will show the interoperability with Revit, an architectural BIM modeling system, and we will show BIM 360, a cloud-based data platform, which enables data sharing. As we go through this webinar, you may have questions or comments. Feel free to enter them into the questions area of the interface on the right-hand side. If you don't see this control panel, click on the orange arrow. I'll try to respond as I see the questions. One other point, the excitement of BIM extends to all the partners in the building project. This webinar focuses on the manufacturers, but everyone benefits. We will offer other BIM 360 webinars in the future and expand them to cover all the potential users. But today, the focus audience is the building product manufacturers. You. This applies to both vertical and horizontal construction endeavors, architectural, civil, plant engineering. We know that projects are getting more complicated and the use of modular design is increasing. More and more building products are made in a factory environment and not on the job site. And the project team is more and more using BIM, or Building Information Management, to collaborate. So what does this mean to you? The architect may have one idea of what, say, a railing system should look like for their building. He would then search catalogs for a matching railing. If there is a close match but not exact, the architect may define his unique requirements and loads that into a BIM model. The manufacturer of the railing system would consider the architect's unique requirements and cost out the custom products. They would then have to plan the manufacturing process and raw materials for that product. They add information to the BIM model reflecting their progress. When the finished railing gets to the job site, the construction workers need to install it using the information from both the architect and the manufacturer. Where do they get that data? The BIM model. So what's the common thread here? It's the data. Each of the partners in the project needs information from the others and generates more information internally. But each cares about different things. The architect's concerned about how it looks. The manufacturer is concerned about the details of how it's built. The construction team is concerned about how it's attached. And each uses a different tool. The architect probably uses Revit. The manufacturer uses some mechanical design software like SolidWorks, CATIA, Creo, or Autodesk's own Inventor. And the contractor just wants to look at the model and the drawings. In the past, 2D drawings were used to exchange this data, but this is a slow, incomplete, and error-prone process. With BIM, all partners can use 3D intelligent models, but we have to provide interoperability among all the players. What we're talking about today is how the manufacturer can easily make the data from the architect's BIM model available to their internal CAD/CAM systems, and just as importantly, handle the inevitable changes. So what kinds of building products are we talking about? There's a large number of things like stairs, escalators, conveyors, windows, doors, window systems, concrete, both precast and pre-stressed items, metal or wood frame wall panels, curtain wall systems, wall cladding, both interior and exterior, sunshades, and so on. More and more of the final building is fabricated off-site and delivered as a module. And each of these products have the same data sharing requirement. Okay, so how can we actually share the data? There are three potential workflows depending on the type of products you make. If you are making standard parts, taking advantage of manufacturing efficiencies of scale, then you would publish a catalog and have the architect select products from the catalog. Your design and manufacturing processes don't need any input from the architect. Number two, if you are primarily making configurable products, that is standard components that could be combined or altered in some way, then you need to work with the architects on the particular configuration they need. Starting from your standard assemblies, they might introduce minor design changes to meet the project requirements. This is a lot of back and forth data exchange. If you are delivering custom products defined by the architect, then the source of the data is the architect, and your job is to determine the manufacturing process. Of course, a good architect would always be open to suggestions to improve the product or make it less expensive to manufacture. Therefore, some interaction and bidirectional data flow is necessary. Let's start looking at the catalog workflow. The standard component or catalog workflow is the easiest workflow. The manufacturer designs a component in their favorite 3D mechanical CAD system. Of course, we think it best if that's Inventor, but even if it isn't, Inventor can use associative links to other mechanical CAD systems. CAM output can come from this design, either in the original CAD system or Inventor, to automate the manufacturing process. In Inventor, the model can be simplified because the architect doesn't want or need excessive detail, and defining parameters can be added. This is then output and published as a Revit family to make it easy for the architect to use. These Revit families can be included on an online catalog. Here, there isn't any data flow from the architect, it's solely from the manufacturer to the architect. Let's take a look at this catalog workflow in the software. Here we're going to create the model in Inventor and need to make it available to the architect in Revit. Working now in Inventor, here we see a sunshade assembly design. Although we're only using Inventor as mechanical design software, we could have started with other systems like Creo, CATIA, or SolidWorks, because Inventor creates associative links to any of these systems. So if the model changes in the source system, it changes in Inventor also. If we look closely at the model, we see details that are necessary to the assembly and fabrication of the sunshade, like these clips and the cutout on the sidebars and the bolts holding it into the building. These are necessary for the assembly and fabrication of the sunshade, but probably no interest to the architect. Brackets, mounting plates, bolts, hardwares are all in the manufacturing model. If we look at the drawings for this component, we see the drawings include all of those details that aren't necessary for the architect. We can use this information to go into the CNC toolpaths for cutting out the oval openings on the side piece or creating CNC for other machine in the shop. We could unfold the sheet metal, nest it, and then laser or water jet cut in the shop, all done through Inventor. All right, let's go back to the design. We need to share this model so that the architect can easily include our design in the building. In Inventor, there's the ability to directly create an Inventor family. But first, we should simplify it. The shrink wrap function allows you to create a single part from a complex assembly. Although this assembly is fairly simple with about 20 components, real-world assemblies would have hundreds or even thousands of components. So simplifying the assembly into a single part can save a lot of time and space and complexity for the geometry. So we're going to go into the shrink wrap and make it simpler. And there's a couple of reasons why you might want to do that. First, the manufacturing model is typically way too detailed for the architect. Making a Revit family with all of that detail will create an overweight, bloated object, which would impact the performance of the BIM model. Second, you may have proprietary or intellectual property in your model that you don't want to share with others. And third, by keeping the manufacturing specific details in-house, you can optimize your internal process without having to coordinate with others. Okay, in the shrink wrap dialog, you can exclude parts by size. So I can go in here and say, I want to remove all parts from this assembly that are smaller than a 3" by 3" by 3" cube. So now you see the bolts have disappeared and the brackets have disappeared. We can also select components to remove from the assembly. So let's remove the mounting plates. So what we have is simply the sunshade that's going to be attached to the outside of the building. This makes the Inventor model lightweight, easy to use, and just what the architect needs. One more thing we should do is locate the placement or origin point. The origin point for the Inventor design, when you're doing mechanical design, could be one thing, but the placement point in the Revit model may be someplace else. So in this case, what makes sense to the architect would have a placement point on the face of the building at the center of this sunscreen. So I'm going to create a point in Inventor so that we have a place to put the object. So this is going to be our placement point. I don't think I finished the shrink wrap, so let me go back and finish the shrink wrap. Because I don't want that. And there we go. So now I've got a single part is the shrink wrap part. Let's put that point in again. So here's the point that's going to be used for placement. So now we're going to go and we need to turn it into a Revit family. So in the Inventor world, it knows that there's lots of environments Inventor could be used in. It could be used in mechanical design, it could be in the manufacturing, or it could be used to communicate with BIM world. So there's a command in the Environments tab that lets us create BIM content. In this construction of objects going into the BIM world, we have the ability to author these components and give information about them. If the component is a mechanical piece of equipment, like a pump or a chiller, we could add connections to conduits, to ducts, to pipes, or electrical connections, so that when you design this mechanical equipment, you can also tell the Revit MEP engineer how to hook it up. So it isn't just the geometry, you're also getting intelligence about what needs to be connected. We also can control the coordinate system that we're using. So here I want to have a coordinate system on that point that I mentioned before, with the x-axis along that direction and the y-axis along that direction. Remembering that in Revit, Z is up, then we want to make sure that the sunscreen is oriented in the correct direction. So now we look at the properties we're going to give to this particular component. First, we're going to tell the orientation to be that coordinate system we set up. So now you see it's going to be flat with Z up. And we can specify the Omni class. And what Omni class is the ability to specify the component by a classification system. And it doesn't really matter if you use a different core classification system, because this all comes from an external file. And that external file can just specify whatever classification system you're using. So here we would have exterior protection of windows, of openings. So it's an exterior sunscreen. So this is the type of Omni class we're using. And the reason we're doing that is, of course, is that the BIM model needs to know what kind of component it is, because you're going to get schedules, you're going to do extraction of data. The more information you can provide, the better the BIM analyst and the BIM model is for the use all downstream. And the other thing that's important here is that the Revit category, when we import this family, we can say this happens to be a specialty equipment family. So that's the category we're using in Revit for this family. So we say that's what we're using. So now we know it's this Omni class, that it is a specialty equipment, and we can have some properties assigned. So the manufacturer, of course, this is the thing I'm most interested in. I want to have them know where to buy this. And this is a model 104 from Acme Sunscreen. So the family needs to go out with these properties. So again, from the BIM model we do purchasing, you want to make it easy for their purchasing person to buy your sunscreen. That's pretty much the idea here. All right, so we put in we could put other properties in here too. We put in finish, materials. You could put in weights, center of gravities, because Inventor knows these things, of course. So it's easy to transfer them over to Revit. And again, this might be useful in your BIM model. So let's finish all through. Now we can export this component to a Revit family. And of course, we're going to save we need to save the assembly and the shrink wrap part first. And now we're going to create the Revit family. So I'm going to put it into a folder called Revit, and it's going to be called Frame Shrink Wrap 1. And we're going to save it. So what this is doing is taking the geometry from the Inventor model and making a Revit family from that geometry. Now this geometry doesn't look very complex, and as if we've simplified it to make it easy as possible, but recognize that those sun-shaped ribs are elliptical in shape, so we're getting the true geometry there. They aren't being faceted or simplified in the sense of making them into rectangles, but they are true ellipses. And in Revit family, those are also going to be true ellipses. So even if you have complex geometry, this process can handle that and give the complex geometry to Revit if you need to. And it does create a report that identifies exactly what it did. If you want to manage your families and make sure you keep track of revisions of families and tie those revisions of the Revit families to revisions of your mechanical design. Okay, so we can see how easy it is for a manufacturer to create Revit families from the product designs that they already use in Inventor. So the same designs you're using to create the manufacturing information now are used to create the Revit family. So let's take a quick look at Revit and see how the architect could use that. So we are now in Revit and we're looking at a building in Revit. We need to load that family into Revit. So I'm going to do insert load family. And I'm going to go to where that data is stored. So here's the frame shrink wrap _1 that we just created. So this is the family I want to load into my project. Then when I say I want to go and let's look at the floor plan, I'll put it over these two windows here. So I'm going to create that. It's a specialty equipment, so it's under the components, and this is the family. So I get a little preview and say, this is the family I wanted, okay? So now I'm going to take this Sunscreen, and it's a Revit family, so the space bar rotates 90 degrees. This is what I was looking for, so I can rotate it. The placement point is at the middle, at the top. I want the elevation to be placed in at 9.3 above the floor. And the placement point is going to be at the center of these windows. So I'll put one there, and I'll put one there. And you notice that the geometry is still elliptical. You've got all the information for that sunshade. For the architect, this is really all they need. They don't need the brackets, the plates, or anything else. So that process we just went through would be catalog workflows, where you have a product that's standardized. It's almost like a catalog. You create the Revit family as an RFA, and the architect brings in that RFA file and places it in the building. And of course, if we do scheduling, we'll be able to see all the information about these components. For example, on this particular component, the manufacturer is Acme Sunscreen, the model is 104, so if I schedule all of my sunscreens, I'd have this information listed. All right, so that's going from the manufacturer to the architect. Now let's look at the other way around, where the architect provides the design and the manufacturer makes it. So this is a totally custom sunscreen. Using Revit, the architect for this building has already created a different kind of sunscreen, probably making it a built-in place family. This geometry can be linked into the Inventor model for further detailing it. And once you have that, then the manufacturing methods can be decided and optimized. So here, the architects made this a sunscreen using some in-place modeling. So what we want to do is to get it to Inventor, but we don't want to send the entire building. The Inventor doesn't need all the building, they just need that one sunscreen. So what we can do is create a new view. So I'm going to duplicate the 2D view and hide everything except specialty equipment. And hide all of the other sunscreens, because we got a bunch of other sunscreens here. So I now have a new view that I'm going to rename as Sunscreen. Spell it right. So I have a view called Sunscreen, which has my custom sunscreen that the architect designed. And let's save that. Now let's go to the manufacturers. So we're going to be in Inventor. And in Inventor, knowing that the architect has already created what they need in terms of the sunscreen, obviously the architect has done a very rough model. They're saying this is the shape and this is the overall size, but it's going to be left up to the manufacturer to decide the manufacturing process, to decide how to break those into parts, how to mount it, where the bolts are, all of those kinds of manufacturing decisions. But they need to start with the shape provided by the architect. So in Inventor, we're going to careful, I'm not in Revit, I'm in Inventor. So in Inventor, I'm going to open, and when we open files, I wanted to mention that there's a lot of different formats we could use. Remember I said before that you can use other mechanical CAD systems like SolidWorks or Solid Edge or CATIA or a Creo or parametric technology. So you can use other mechanical systems and still bring that data into Inventor so the Inventor can work on it and share it with Revit. In this case, I of course want to get my Revit model, so I'm going to go and open a Revit file, and the Revit file was stored under here, under building base. That was today's date, and I'm going to open that Revit model. So it's going to say, all right, I see this entire Revit model, but before I bring it into Inventor, I'm going to give you the choice to choose a view, and only the objects that are in that view would actually come into Inventor. So remember that in the Revit side, we made a view called Sunscreen, which just showed that one special sunscreen, and that's all we need. So I can say, all right, here's the model, there's the building, and here's a view called Sunscreen, and that is all I want to bring into Inventor. And now we've got it. So now in Inventor, this is the sunscreen. And now the manufacturer, using this geometry, can do some design work based on it. For example, maybe they've got to create some end plates. So we're going to create a new part, an end plate, and we'll put it there. And I want it to be the same shape as what the architect gave us. So I'll project geometry to guarantee that it's the same shape as what the architect gave us. And I'll create an inch thick component. And that's going to be our end. Let me paint it a brighter color so we can see it. Yeah, sky blue. There we go. So I've got that part, and I probably want another end plate at the other end. So I will bring another one in and constrain it so it stays stuck on the end of the so it stays stuck on the end of the sunscreen that the architect designed. Okay, so now we've got the sunscreen, we've got two end pieces, then we can start doing some brackets and figure out exactly how we're going to put this onto the building. But what usually happens at this point is that the architect changes their mind and they say, oh, I really want something different. So here we're the manufacturer, we're the tail being wagged by the dog, but that's fine, they're the ones paying the bill. So if the architect does decide to make a change, now we have to be able to respond to that. So let's come back to Revit, and here's the architect's model. And maybe the architects looked at this and maybe they've done some shadow studies, and maybe they've decided that they need more protection in the July sun to protect these windows. So they've now said, I need this sunscreen to be bigger. So they drag it out like that. This is the sunscreen I really want. So now let's save that file and come back to Inventor. So the manufacturer has to update their file to accept that the architects changed their mind on what that sunscreen looks like. Well, because it's an associative model, because we got that data from the Revit model, there's an update capability. And I could say, go back to that Revit model and update this model to match. And of course, the geometry changes, the end plates change because they're also forced to be the same size as the design. And now everything is updated. And of course, if I'd gone from this design into manufacturing, where I create CNC paths or nest it, or even use it out of sheet metal, unfold it, all of those would update automatically also. So with this process, you know that what you have in Inventor is going to follow what the architect has in Revit. And now suppose that the manufacturer wanted to make a suggestion to say, you know, it'd be a lot cheaper for us to manufacture if we made this not as one piece, but as different fiberglass pieces. The manufacturer could make that design, and then as we did before, shrink wrap it, simplify it, create a Revit family, send it back to the architect. The architect could then bring in the new Revit family and see what it looks like in the place of this family. And the architect could then say, yeah, I'd like that one better, or no, let's stay with the original. So having this flow where we can go back and forth means that the architect and the manufacturer can indeed work well together. So what we were showing in that last flow was that the architect designed a Sunscreen in Revit. It came to Inventor. We were able to use it for all the manufacturing and detailing. And if we'd wanted to, we could have sent that family back to Revit to update the architect. So it becomes a closed loop process, keeping everybody up to date with the design. All right, so why have I been stressing Inventor? Because only Inventor provides out-of-the-box functionality that fits so well in the building product and fabrication workflows with BIM and Revit. Models built in Inventor can be transformed into Revit families for architects' use. The Inventor models can contain the intelligence to let these families be used by Revit's analysis tools. The models become part of the BIM model, usable by everybody on the project. And because Inventor can link associatively with Revit models, the geometry created by the architect can be part of the Inventor model. And it updates automatically when the architect updates the Revit model. The intelligent model can contain additional data for asset control and facility management. So we see that Autodesk provides the workflows to exchange data among all the partners on the project, but what makes it particularly useful now is that all of these products support intelligent information sharing on the cloud infrastructure provided by Autodesk, the BIM 360 platform. This is especially important now that designers have become used to working from home. Revit users can design with their models in the cloud, securely sharing their data with whomever they wish. Inventor users can access the same data, just like I showed you, incorporating it into their designs. On the BIM 360 design platform, the software keeps track of versions of the design and controls access. So all users can view, markup, create, or respond to issues without having either Inventor or Revit on their computer. And the access is on any device, laptop, tablet, phone, and anywhere there's an internet connection, in the trailer, in the office, on the site, wherever you need access to the data. So single data platform for data, BIM 360. The world's top software for BIM, Revit, and the world-class manufacturing design CAD/CAM tool, Inventor, all from Autodesk and MicroCAD. All right, before I catch up on the questions, and there are a couple out there, thank you for your questions. Let me mention that MicroCAD will be running more webinars about BIM and cloud services. So take this opportunity to tell us what topics you would be most interested in by entering them into the question area. We really want to address your needs. So let's go on to the questions. Yeah, so somebody came back with a question commenting that their products are a lot more complicated than what we're showing. You know, when you're talking about complex kitchen assemblies and modular construction, absolutely, those are much more complicated. What we've done today is just had some simplified models because in a demo environment, we wanted to focus on the process rather than the data. But in fact, the benefits that you would get would be much greater for a complex product because there's no way the architect could recreate the geometry from one to the other. So this process means that people don't have to try and emulate what you're doing. They can take your data directly and vice versa. You can take the architect's data directly without having to do any complex translation or recreation. So in fact, you get more benefits the more complicated the problem is. So thank you for your comment. I hope it wasn't meant to be negative because actually it's very positive that we use simple models just to give you a flavor, but the complex models are where you're going to make your money. Okay, another question. Do I need both Revit and Inventor to do this? So obviously, if you're the architect and you're doing the design, you need Revit and you don't need Inventor. If you are the product manufacturer, you don't absolutely need Revit and you do need Inventor. However, there's a lot of users who want a single seat of Revit just simply to verify the models coming in from the architect and to check out what they're doing. And it's a small price to pay to avoid mistakes. So you don't need to become a Revit guru. You won't be needing to author anything Revit, but it's useful to be able to navigate around the Revit model and understand what the architect has in mind. So in our example for the architect gave us a sunscreen, we may want to, as the sunscreen manufacturer, take a look at what the architect's really trying to do, look at where the sunscreen lives on the building, and maybe we could offer some suggestions to the architect on some alternate designs that would be more effective to achieve their purpose. So certainly, if we have expertise in that particular product, the architect would want to share that expertise. So it might be useful to have a single seat of Revit just simply to enable the collaboration, but it's not necessary. All right, another question came up. They're using AutoCAD now for their design and manufacturing process. They have stuff automated already, and they see this as the question was, do they need to replace everything with Inventor? And the answer is no. If you've got something, if it ain't broke, don't fix it. So if you're using AutoCAD now and you've got a CAM process that's driven by AutoCAD, whatever you set up there, then don't mess with that. However, the design part of the product design, you do want to get into Inventor, and you can get into Inventor in 2D or 3D, and that's what you would share with Revit, primarily in a starting from a 2D and turning it into a 3D model, and then in the same way getting 3D models from Revit, and in Inventor we can create 2D drawings which AutoCAD can open up as if they were AutoCAD drawings. So we can coexist and work very nicely with AutoCAD without losing any data. So if you have policies and procedures in place already, you don't have to replace them. All right, any more questions? All right, there not being any more questions, I want to thank you for taking the time today to attend the webinar. I hope you found it useful. We'll be continuing this series of BIM webinars and adding new topics. Keep watching www.microcad3d.com as we add more webinars to the series. If you want more information, feel free to contact me directly or any of the MicroCAD offices. We would love to talk to each of you and discuss how the tools we've showed today could improve your productivity and smooth your workflows in the BIM project. Thank you again, and this ends the webinar.